The next presentation is going to be Pascal Noel, and Pascal's paper, you'll see fits very nicely into this discussion, that already Arpit started out, with his paper about, why individuals default on their mortgages. This was also, a little bit an element of Teresa's presentation. This idea, how much is it just strategic default? How much is it just liquidity? How much do you need this double trigger idea? And how would you go about in the data to even think about looking for these types of, different motivations? So Pascal, we look very much forward to hearing your presentation, and the floor is yours.
Great. Thank you so much. Thank you all for joining, and thank you, Johannes and Teresa, for asking me to do this. Let me try to make sure I can share my screen.
Perfect.
Okay, we're good. Great. Okay, thank you. So I'm going to be presenting a paper that is joint with my co-author Peter Ganong. And one thing from the PhD students' perspective is we started working together in graduate school and actually co-authored both of our job market papers together. And that was something that I found really enjoyable in graduate school, and that we've continued working together since becoming assistant professors. So the question that we are going to try to think about is why borrowers default on their mortgages. And one reason this is sort of important, one motivation for this is that obviously we saw the significant increases in mortgage defaults during the Great Recession, and the mortgage defaults sparked the greatest financial crisis since the Great Depression. And policymakers who were dealing with this crisis and defaults face a dilemma. So Federal Reserve Chairman Ben Bernanke noted that one of the main challenges was trying to understand why borrowers were defaulting in the first place. And on the one hand, Bernanke noted that sometimes a mortgage default can be triggered by some life event, like the loss of a job, illness, injury, or divorce. And of course, the unemployment rate, one of these types of life events, obviously rose dramatically during the Great Recession. On the other hand, Bernanke and other policymakers were also quite concerned that another factor was playing an increasing role, which was negative equity. And of course, as we all know, house prices, which are shown here in the purple line, also fell dramatically during the recession. So sort of to sum up, there was a dilemma facing Bernanke and other policymakers, which was it was difficult to tease apart these two stories for why borrowers were defaulting. Now, in his speech, Bernanke went on to note that this was sort of a novel problem that were facing policymakers here, but hadn't been there in previous times. However, housing economists, like many of us who are presenting today, recognize this as just the latest chapter in a long-standing debate between two sort of formal theories of mortgage default. So the first theory is that default is a function exclusively of negative equity. So under this theory, borrowers are making an option value calculation and deciding to walk away from their mortgage when the value of selling the house in the future is worth less than their mortgage obligations. So because this is a function, this type of default is a function of the value of the house as a financial asset and nothing to do with the borrower's individual circumstances, it's sometimes called ruthless or strategic default. And so I'll often use the terminology of strategic default, talk about sort of negative equity driven default. The second theory is that default is a function of borrower cash flow. So according to this theory, borrowers have some life event like the ones that Bernanke mentioned on the quote in the prior slide that makes it difficult for them to come up with the cash to make their mortgage payments. Now, of course, it could be some combination of negative equity and cash flow that are driving mortgage defaults, according to this so-called sort of double trigger theory of default, which is that you need both negative equity and cash flow triggers in order to drive a default. Now, there's a substantial prior literature on this topic. There's about sort of like two waves of the literature. The first was after the real estate crisis in the early 80s. And then there's been a renewed wave and renewed interest in this question, of course, since the Great Recession and since the major spike in mortgage defaults and foreclosures. there's actually been about a dozen recent papers who have specifically run a horse race between negative equity and cash flow and trying to explain borrower default. Yet, according to a recent review article by Chris Foote and Paul Willen, who are researchers at the Federal Reserve who've done a lot of work in this area, they've argued that disentangling the role of life events from that of negative equity remains one of the central questions in this literature. And so that's the question that we try to make progress on in this paper. So the goal of the paper is to separate the strategic defaults where negative equity is driving the default and life events are irrelevant from cash flow and double trigger defaults where life events play a central role. To help clarify the research question and the debate in the prior literature, we specify borrower types in terms of potential outcomes. So we're going to label a default as strategic when negative equity is a necessary and sufficient condition for the default, as a cash flow default when a life event is necessary and sufficient, and double trigger when both life events and a negative equity are necessary. One thing I want to be clear about is that there's sometimes some debate about exactly what the definition is of strategic default. And what I want to be clear about is in this paper, we are taking a specific definition in terms of potential outcomes that builds on a common way of defining this in the prior literature. But what basically we're going to be identifying is the share of defaults that are strategic in the sense that negative equity is the causal driver of the default. And it's necessary and sufficient. You don't need any other trigger to drive this default. Now, if there's been a substantial prior literature on this topic, why is it even an open question to try to separate these strategic defaults where life events are irrelevant from the cash flow and double trigger defaults where life events are necessary? There's basically been two main challenges in the literature. The first is a data challenge. So mortgage servicing data do not record life unemployment or other potentially triggering life events that might be causing mortgage defaults. So as a result, prior work has often had to use coarse measures of life events like regional unemployment rates. If you're trying to use regional measures or coarse measures to explain default at an individual level, you might have measurement error and therefore attenuation bias. And you might inadvertently classify a borrower as strategic when actually in their individual financial life, they actually have experienced an adverse life event. So to try to overcome this challenge, the first ingredient that we try to bring to the table in this paper is a new data set that links default to contemporaneous income information for about 3 million borrowers. And we do this by linking administrative mortgage servicing data to administrative bank account data. The second is that even once you have a data set where you can look at a borrower who has defaulted and look at their financial circumstances at that time, you still need an empirical criteria for deciding what does it look like when there is a default that is caused by a life event. And so for this, we use the second ingredient, which is that we propose a methodology that uses a comparison group of defaulters with positive home equity. So the central idea behind our approach is that if you have positive home equity, which means your house is worth more than your mortgage, you can't possibly have a negative equity reason for defaulting. You can't possibly have a strategic reason for defaulting. And so if you default with positive equity, it must be because you have experienced some sort of adverse life event. Therefore, the income losses before default for borrowers with positive home equity is going to give us an empirical benchmark for what it looks like in the data when we know a life event is causing the default. When we put these two ingredients together, the central empirical conclusion of the paper is that only 3% of defaults are strategic, or in other words, that life events are a necessary condition for almost every single default. This share of defaults that are only driven by negative equity is much smaller than some of the results in the prior literature and smaller than what you get out of standard models. And so I'll spend a little bit of time talking about how you can reconcile these estimates with some of the model and empirical estimates in the prior literature. All right, so for the next 15 minutes, I'm going to go through the data very briefly. I'm going to talk about the empirical results. I'll talk a little bit about some robustness checks, and then I'll compare it to the results that you get to standard models, structural models of mortgage default, and explain how you can reconcile those with the data. So to introduce the data, after the first wave of mortgage defaults research in the late 80s, early 90s, there was a literature review by Kerry Vandell, and the literature review concluded that what we need to make progress on understanding why borrowers are defaulting is a data set where we track a panel of several thousand mortgages from origination and gather detailed information whenever termination occurs. Now, after the second wave of mortgage default literature, there was this review that I already mentioned by Foote and Willen in 2018. And usually when 23 years have passed between literature reviews, you say, look how much progress we've made. However, they basically concluded the same thing. They said, what we need to make progress here is, again, to develop data sets that match labor market experiences and default behavior at the individual level. So the point of saying this is just that this has been an enduring challenge for making progress on this question in literature. Data has been difficult to come by. It's hard to figure out for a borrower when they're defaulting what's actually happening in their financial life. So to try to make progress on that, we use a data set that merges two things. The first is very standard, and this is the type of data that's already been mentioned in several of the papers that you've already seen today. So it's administrative mortgage servicing data. Ours comes from JPMorgan Chase. And from this, we basically take two things. The first is a measure of default. So it's borrowers who have missed 3 mortgage payments, so 90-day delinquency. The second is loan to value ratio. We need to know whether the borrowers have positive or negative equity. We calculate that by taking the total mortgage debt owed on the home, including second mortgages, and deflate that by a measure of the house's value by taking the purchase price and inflating it by the price index. We have some robustness on this that I'm not going to talk about much today. The second piece of information is relatively novel. So we have linked bank account information. We know borrowers' bank account balances all the way back to January 2007 for about 5 million households. And then we also observe income going back to 2012 for about 3 million households. We actually, one side note is that we're recently made available income data going back to 2007. So we can observe income like at the peak of the Great Recession, and we're finding very similar conclusions. All right, so now let me show you the main estimate. And key thing is that you can sort of summarize all of the empirical results in this paper in one slide. So I'm gonna try to go through that now. So what I'm showing you here in green is the evolution of monthly income in the year before default for borrowers who default with positive home equity. So what we see is that for most borrowers who are defaulting with positive home equity, their incomes are relatively stable, and then they start falling about 6 months before default. So this is consistent with the idea that these are borrowers who are suffering some sort of adverse life event, something bad is happening in their financial life, and it ends up being that they end up defaulting on their mortgage. Now, this is the benchmark for what it's going to look like in the data when we know a default is caused by a life event, by an adverse life event. Because borrowers who have positive home equity can't possibly be defaulting because of negative equity. So we know it must be something else. We need another benchmark, which is what would it look like in the data if a borrower was just defaulting because of negative equity. And so for this, we look at the evolution of income for all borrowers who have negative equity. The basic idea here is if you were defaulting because of negative equity and not because of something happening in your financial life, your income would look just like everybody else who has negative equity, and it would be relatively flat. So then what we're going to do is we're going to compare the evolution of income for underwater borrowers to these two groups. For the underwater groups, we don't know a priori if they're defaulting because of an adverse life event, in which case their incomes would look more like the above water defaulters who we know have suffered a life event, or whether they're just defaulting because of negative equity, in which case their evolution of income would be closer to the everybody else who has negative equity, or if they're somewhere in between, so some of them are defaulting strategically and some of them are defaulting because of life events, we would see something sort of in between these two lines. And this is what we find. So the evolution of income in dark blue for borrowers who are defaulting with negative equity is statistically and economically indistinguishable from the evolution of income for borrowers who are defaulting with positive home equity, who we know must be defaulting because of adverse life events. So this is the central empirical finding of the paper. So if you remember only one slide from today, I hope it'll be this slide. The main point is that borrowers who default with negative equity have exactly the same evolution of income before default, exactly the same income drop as borrowers who default with positive home equity, who we know are defaulting because of life events. Therefore, it's reasonable to conclude that the underwater borrowers are also defaulting because of life events and not for strategic reasons. So now the question is, what causal quantitative claim can we make based on comparing the paths of income for these borrowers? What can we say quantitatively based on the figure that I just showed? And so for this, we turn back to our potential outcomes notation. And I'm going to show you a summary of it. The details and the proofs are in the paper, but I don't have time to go through it today. But I'm showing you the same table that I showed you in the introduction, but now I have three other columns that add potential outcomes notation. So default Y is a function of life event treatment T and negative equity group G. So the strategic default types are a group that will default just with negative equity G, but won't default if all they had was life event treatment T. The cash flow default is a borrower who wouldn't default if all they had was underwaterness, but would default if they had some life event treatment. And the double trigger group is a group that wouldn't default just with negative equity or just with life event, but will default with both of them. Now, we define a parameter of interest that we're going to call alpha. And it's just what is the difference between the expected outcome in the population and the expected outcome in a counterfactual world where we've evaluated the outcome, the potential outcome function in the absence of treatment T. So this is a common estimate in applied microeconomics. It's, what fraction of some outcome would be eliminated if you eliminate some treatment. And for us, it's what fraction of defaults would you eliminate if you eliminate life events, or for what fraction of defaults are life events a necessary condition. And you can see from the potential outcomes in this table that this is measuring the combined size of the cash flow and the double trigger rows where life events are a necessary condition. So the key thing we show in the paper is that under plausible assumptions, you can identify this parameter, and all you need is 3 inputs, and it's exactly the 3 lines that I just showed you in the prior slide. You need to know the change in income for the underwater defaulters, which are the group of interest, which is the blue line that I showed you in the prior slide. You need the change in income for the above water defaulters, which was the green line that I showed you in the prior slide. And you need the change in income for everybody who was underwater, whether they're defaulting or not, which was the purple line in the prior slide. And the intuition is exactly what I showed, is that you want to compare the evolution of income for the group of interest, which is these underwater defaulters, to 2 benchmarks. One where you know that life events are driving the defaults, which are above water defaulters, and one where life events are irrelevant, which is everybody who has negative equity. So we can just plug in the numbers from the prior slide into this equation, and we get 97%. So that means that 97% of defaults have have life events as a necessary condition, or 1 minus alpha, which is 3%, are strategic, where life events are irrelevant. So that's the central conclusion from the paper, is that only 3% of defaults are strategic and 97% of defaults are double trigger. So now let me try to put this a little bit in the context of the prior literature. So the prior literature has tended to find actually a much larger role for strategic default. So between 30 and 70% of defaults are found to be strategic in the prior literature. We're finding about 10 times less, so only 3% of strategic default. Now, why are we finding a much smaller estimate? It goes back to something I said at the start of the talk, which is that because we haven't had individual level data about life events at the time of default, people have had to use coarse measures of life events, either regional unemployment rates or from surveys, et cetera. And when you're using coarse measures, you might end up with measurement error and therefore attenuation bias. And so you underestimate the role of life events and overestimate the role of negative equity. The second comparison is that the prior literature has thought, okay, if 30 to 70% of defaults are strategic, then the rest of the defaults must be double trigger, where you need both negative equity and life events. And there's clear evidence that double trigger behavior is very important, and negative equity does causally increase the likelihood of default. And you just saw a very convincing paper by Arpit Gupta and Christopher Hansman that shows this clearly. At the same time, negative equity can't be a necessary condition for all defaults. So we don't think that this cash flow group is actually zero, because we've just shown you that there's plenty of above water default where negative equity isn't even present, yet borrowers are still defaulting. So one key question is, can we break out this 97% between the cash flow and the double trigger rows? And we can do that if we combine our estimates with estimates of the causal impact of negative equity on default from the prior literature. And the first key paper we use is actually this paper that you just saw from Arpit and Christopher Hansman. And when you do that, you can sort of decompose this 97%, and you can figure out, of all of the defaults, how do we bucket them? So 3% are strategic, 50 to 75% are solely due to cash flow, and that means that a quarter to a half are double trigger, where you need both negative equity and adverse life events. So the first lesson that comes out of this is that a substantial share of defaults are exclusively driven by cash flow, at least half, and at perhaps as many as 75%. The second is that we can now decompose each of the channels on an equal footing. So if you eliminate life events, you would eliminate 97% of defaults in a counterfactual world. If you eliminate negative equity, you would eliminate a quarter to half of defaults. So negative equity is still relevant, but life events are driving the vast majority of defaults. I'm going to show you 2 slides on internal and external validity, and then I think I'm going to conclude to make sure we end on time. So
you can go into the break if you want. I mean, we have a 15-minute break after you. So
okay, I'll show the model then. The first is what I showed you previously was the means, but for above and below water, just cutting off at 100 loan to value ratio. But you might be wondering, well, let's look further underwater or more above water. And we can do this in finer grain bins. So you can see here for borrowers who have very, very positive equity, less than 60 loan to value ratios, to very, very deep negative equity, you find almost exactly the same income drops. And in fact, it's not until we get to negative equity of over 220% that we start seeing evidence of strategic behavior. It's there, but it's in a very small subset of the population. The second is I was showing you means, but you might be wondering about the distribution of income drops for these groups. And again, we can do the entire distribution and they look very, very similar. There's other robustness checks that are in the paper that I'd be very happy to talk about if we get to it in the discussion, but I'm not going to talk about today. There's other common questions that people ask that I'm also not going to talk about more, but I'm going to spend about a minute or two talking about the model. So basically, we find that borrowers are not walking away from their homes, even when they have substantial negative equity. That's sort of in contrast with some prior empirical evidence, but it's also in stark contrast with standard models of mortgage default. If you write down an optimizing model of mortgage default, where households are making a rational financial decision, if you have a financial asset that's deeply underwater, they should exercise their option to default and walk away from this asset. Yet that's not what's happening in the data. So to try to make this point crisply, we compare the predictions from a standard model to what we observe in the data. And for this, we use this model by John Campbell and Joel Coco from the Journal of Finance in 2015, which is sort of the first iteration of sort of what I would say like the modern benchmark model of defaults. And what they have in this, the key feature of this model is they have both an option value driven decision of default that's based on the value of the house as a financial asset, and they have cash flow motives for default because they have realistic income shocks for the borrowers themselves. So if any type of model is going to be able to match the data, it's going to be this type of model. And so I'm comparing the income dropped before default for borrowers in our data in blue and borrowers in the model in green. And for borrowers who have positive home equity or are moderately underwater, there's a very close link between model and data. The model does actually very, very well. But when you get very deeply underwater, the model completely breaks down. The model is expecting that borrowers are going to default even without any or very, very low income drops. Whereas in the data, we see that the only borrowers that are defaulting, even when they're deeply underwater, are those that have had a big adverse life event in their life. So how can you reconcile model and data? There's a parameter in the model that governs how costly default is for the borrowers. A key challenge is there hasn't really been data to discipline this parameter. And Campbell and Coco are very clear about this. They say, look, this might be important. We just don't know how costly default is. We don't have a good moment to calibrate this. So we propose to use our moments about the income drop at default as new targets to discipline this parameter. When we do that, we actually can generate results in the standard model that very closely replicate what we actually see in the data. And what you need is that you need default to be pretty costly. You need default to cost about 25% of lifetime consumption. So what that means is that borrowers in the data are acting as if defaulting is very, very costly. There could be financial reasons for this, or it could be a behavioral story where they're overestimating the actual cost of default, or they don't understand how underwater they are. But basically, a high default cost provides one plausible micro foundation for the empirical behavior that we see. So now I'm gonna wrap up. We've tried to understand why borrowers default on mortgages. There's been a long-standing debate about the extent of strategic default in the data. Relative to this debate, we bring two ingredients. The first is new micro data with income before default for about 3 million borrowers. The second is the idea to use a comparison group of borrowers with positive home equity who can't possibly have any strategic default motive that gives us an empirical benchmark for what a default driven by life events actually looks like. We hope that the paper makes 3 contributions using these ingredients. The first is an econometric contribution that I didn't talk about almost at all in my summary today, which is a method for causal attribution when you have measurement error. The second is the key empirical result, which is that only 3% of defaults are strategic, or in other words, life events or cash flow shocks are the key driver or necessary for default for almost all defaults. And then finally is micro foundations, is you can reconcile this data with standard models if you have a high utility cost of defaulting. Okay, that's all I have, Johannes.
Thank you, Pascal. So this, I think this is really interesting. I'm trying to make sense magnitude-wise. So this 25% of lifetime consumption.
Yeah.
Like that seems very high. I would think, like, even, you know, I mean, this must be potentially more than the purchase price of the house. I'm trying to just do like back of the envelope calculations now. But so I mean, I can kind of see mechanically how, you know, if you jack that parameter up high enough, then you obviously, you know, there's going to be at some point where you basically match that only the people who literally cannot pay for the mortgage are the ones that don't, and everyone else, you know, kind of will go through. But it seems almost implausibly high for this to be the only thing. And so then the question is, what are other adjustments you might think that, you know, in addition to this cost parameter, that to the model might help bring down that cost parameter somewhat and still match the data? Do you have any thoughts on that? Or
yeah, that's a great question. We've thought about this a bunch. We don't have any like obvious clear answer, but let me say a few things. The first is that the prior literature has also been estimated a very wide range of these parameters in models that are trying to understand defaults. So the prior literature has gone between 2% and 70% of lifetime consumption. So actually, like, relative to that 70% number, this is pretty low. But as I mentioned, there hasn't been any good way to discipline it before. And so that's why we had such a large range. And so we think this is a good way to discipline it. But when you do, you still get a pretty meaningful number. So what might be going on? So one is, I think that there really could be actual very large costs. And one is people have high attachments to their homes. Oftentimes you might grow up in the house, or you might be raising your kids in the house. You like your neighbors, your kids go to school nearby. There are big frictions with actually having to move houses. There's also recent research by Adam Gurin, Rebecca Diamond, and Rose Tan, who are showing with a foreclosure instrument that when people lose their homes and are forced to leave, you have higher divorce rates for couples. The kids have lower test scores. So there are really like actually meaningful costs that you think about divorce, that could be 25% or more of lifetime consumption. That seems potentially reasonable if like people have place a high value on their house. And then there could be financial costs. You're shut out from credit markets. It's harder for you to potentially find a new job if your credit score is impacted, et cetera. So there might be real costs. On the other hand, it could also be a behavioral story. And that's why I say we don't have a clear test in our data between these two. So the behavioral story would be something like people are overestimating all of these costs. Maybe it really isn't that bad to default. It isn't that bad to lose your house, but because you've never gone through it in your life before, you really are worried about it. It could be something around social stigma that, if you lose your house, maybe your neighbors are gonna think worse of you, and you place a high weight on that. Or it's just that you don't understand that the costs are going to be less than they are. You don't understand that the bank's not going to go after you, as in America, they almost never do. And so you're worried about things that you shouldn't actually be worried about.
Yeah, no, I think it, I guess like as sort of these various categories of things you've talked about. So I think the costs through things like credit score, etc. Like I think they're there, but they don't get you to those magnitudes by themselves, right? So because you do the same exercise for bankruptcy, for example, like do people declare bankruptcy optimally? And there you need those total costs to be somewhere in the order of 10,000. I guess on the people are attached to their house. I think what you need to look for is something specifically about where the cost of leaving the house is very different when it is voluntary than if it is forced, right? So yes, your kids have to change schools. Yes, you like your neighbors, but we see people, move house many, many times throughout their lives within the US. And if each of these was associated with a cost, equivalent to 25% of lifetime consumption, the best thing you could ever tell anyone is just never leave, right? There's no way that a job pays you so much more that it offsets the 25% of lifetime consumption drop that comes through having to move to a different neighborhood, move your kids to school, etc. So I think it has to be something that is, where you're saying the Gurin, Rebecca Diamond paper, where it's an exogenous shock that sort of, where maybe being forced to move has these higher effects on your divorce probability than if you voluntarily move. So it has to be something really specific to that. I mean, the other thing, and here kind of come back to some theme we've had in the class a lot, which I actually think is quite plausible, is this idea of, jointly the information and the stigma. So when I introduced the lecture, one of the things I talked about, why is there, what are sort of the mechanisms through which there's peer effects in mortgage default, which is something, that Alpit shows in his paper and that we see in other papers and in other papers too. And I think, you've basically highlighted the two mechanisms. One is, an information flow. It's basically your friends tell you, what, I walked away from my house and for 6 months, I was worried the bank would come after me, but then I realized they actually just don't. And it's fantastic. And you get rid of all this debt. And the other is a social stigma, which is kind of, the extent of the social stigma is really strongly dependent on just how prevalent default is within your social circle, right? So, and here I'm thinking of the, the Zingale Sapienza survey paper, where they basically, they ask people how morally wrong is it to, strategically default. And basically they also ask people, how many people do you know how much are you friends with people that are strategically defaulted or that have defaulted full stop? And you see a strong relationship that, the more prevalent it is in your social network to default, the more likely you are to say, yeah, you know what, I'm happy to walk away from it. That paper does seem to suggest strategic default, at least in hypothetical scenarios with sort of, not crazy amounts of negative equity. But I guess, would you be willing to walk away in a hypothetical is very, very different to, are you actually going to end up doing it in practice? So I think we have a lot to learn still in this literature, which is kind of exciting. It's as you pointed out, it is still one of the most interesting areas to research. And even though people have thought about it for 20 years, 25 years, why don't we see more mortgage default? There is a question about the strategic versus non-strategic, which in terms of these quantifications, where I don't think there's like a true time this is not like a deep preference parameter, right? So, in different economic environments, the relative probability assigned to these might differ, and you could think about sort of time varying economic things like, the overall cost of default might be very different if you default in a crisis versus if you default during a boom period, right? In a crisis, it's much easier to blame some systematic shock. If you do it in a boom period, it's if you do it in a boom period, it really has to be like your fault type thing.
One really quick thing that surprised me is that we've now redone this in every year from 2008 through 2015, and we get essentially the same estimates. And so like people seem to be behaving very the income drops that are driving defaults are different because the economic environment is different, but the underwater borrowers are behaving just like the above water borrowers. And so it indicates very, very little strategic default throughout that time period. However, I think absolutely you could imagine a future scenario where the dynamic in the environment is very different. Like if you had a president that was like, look, I defaulted on all my hotels, everyone else should go out and walk away too, maybe that would change it, but we haven't gotten there yet.
That's really interesting. So thanks very much, Pascal. This was really exciting, and I think we'll have a few more things to bring up in the panel discussion. I think one thing that we always talk a little bit about, because I think it's very relevant to PhD students, is sort of how to work with some of these sort of more restricted data sets. And so obviously you and Peter have this sort of great relationship with JP Morgan. So just some sort of general advice based on that, I think we'll come back to you on that.